Hello, everybody. This is part one of assignment 14. We're going to be looking at some decision trees here in Orange. Um, we got our initial information over here from assignment 13 that we were working on, where we started using this k-means clustering widget, and then we broke down two different data tables, if you guys remember the initial one, and then the data table after we broke down the k-means clustering that broke it into clusters, into different clusters. So we're using that data now in assignment 14. So this is the part one. I'm using the housing data to look at this information that we're working with. And the two subsequent parts, we will look at the other data that I used for the other ones. But this one is for the housing data. So what I did, I went in here and I input the housing data that I had with the clustering and reloaded it. And then for the select columns, what I did was I took out silhouette and then I added cluster to the target variable. And that's what we were looking for here. For the tree widget, this is kind of where we can mess around and play with different things to interpret our trees. As you guys remember from class, the fast and frugal trees that we were talking about, I was trying to play with them to mirror kind of that so that we could look at some of those similar pieces of that in what we were doing here. So let's see here. So this is what we're looking at. I will bring up this. So this is what I did is I changed the numbers here in the leaves to 5 and 5, and then maximal tree depth to 20. So we'll play around with that a little bit as we move forward. But this was the housing data. So here at 5 and 5 with our top node here being the INDUS. So we'll look at that over here. The INDUS over here on 13. So that is proportions of non-retail business acres. It's just interesting that Orange pulled that one up as the most important variable for that particular cluster number. And then here, if you can see that it goes to two different places, the arrows point to two different places. One is crime, where crime is less than this, it would go into these three different clusters. And then ZN over here. Let's see. I don't know where it went, but this one, you see it breaks it out into age, and we'll just focus on this little cluster of trees over here. When you get to crime, less than 15 number of crime there, it goes to air pollution here. And then air pollution, from there it goes to RM and LSTAT. So LSTAT is percentage of lower socioeconomic status population. And then the other one is that one. So kind of interesting to look at those. Let's change them up a little bit here. So let's get out of this and let's make these bigger. Let's go to 8 and 8. And then we'll leave that at 20 and see what that does for a tree. INDUS, let's see. So proportion, so pick the same most important node, and then it picked crime. This one's very similar. It just has a little bit of switch out here with the air pollution and the median value of homes and age. So very similar. Let's try and change it a little bit more here to get a little bit more fluctuation. Let's go to 12. And then we'll make this guy smaller. Down to 7. Look at that. So started to change a little bit. You know what? Let's take this one down to 4. And then we'll take that one to 10. See what it does. So kind of neat that you can look at this in real time and watch it change. You can see what it did to our 3 clusters here. Very similar as it moves around some of the qualifying variables. But that's the first decision tree that we were able to create based off of the housing data. In part 2, we'll use our second data, but that's what we were able to do for part for part one, as we interpret the median home values, the air quality, the crime, distance from um, highways and things like that. So that's what we got for that one.